We just had a lecture on the index of refraction. We were looking at light and boundaries and how light tends to bend toward the normal inside denser environments, and it bends away from the normal when it enters optically less dense materials. So we're going to continue on that topic, and we're going to be taking a look at two things today. We're looking at mirages, and we're also going to take a look at how light conquers darkness. So let's go ahead and we'll first take a look at a mirage. So imagine that you're driving down the road, it's a super hot day, and you see those little swirly mirror-like puddles in the road in the distance. That would be a mirage in what you're seeing. I want to help to explain what is actually happening. So imagine that you've got an object over here. Okay, I'm just going to draw this object as a triangle. Let's say this is a tree, a car, or even could be the sky. It could be just the mountain in the distance as well. And you are standing here, okay, or driving here. Okay, I'm going to draw this person very tall like this. So we have the sunlight that's coming down, and it's going to be hitting this object. Now imagine somebody is sitting in the middle of the room. Okay, people on the left can see this person, people on the right can see that person, people in front and people in back can see that person, and that's because the light from the lights is hitting that person and it's bouncing in all different directions. Okay, so the light can be coming in from the sun here and then bouncing off here. Okay, it could be coming in here, it could be bouncing off there. Meaning that these rays of lights, if you were to put your eye in front of that, you would be able to see that object. If there was a person standing here, they would be able to see this object. Well, this person is actually able to see this object as well, because there's going to be a beam of light that's going to be coming off this object and into the person's eye. That accounts for being able to see the object. For example, you see a car coming in the distance, but you also see that silvery, shimmery mirage. So we're going to explain what's happening with that right now. So imagine that all of this air that's from the top here down below here is now divided into an infinite number of very, very thin layers. Okay, so let's go ahead and draw this. Let's say this is going to be air at 1.00. Okay, imagine this is a very, very hot day. So we have mirages on a very hot day. Okay, and so what's going to happen is down towards the road or the blacktop that we see here, this asphalt material or the cement, this is where the sun is hitting, and it's making the ground very, very warm. It's absorbing all of this electromagnetic energy in the visible spectrum, also in the ultraviolet, and it's going to re-radiate that as heat. So it's going to be very, very hot near the surface. But as you ascend, you're going to be getting farther and farther away from this blacktop or this asphalt, and it's going to get cooler and cooler and cooler. So we've got hot, and up top here we have, it's going to be cooler. So if you remember, this is going to be affecting, the temperature is going to be affecting the density. It's also going to be affecting the optical density. So this is going to be optically less dense right here. So it's optically less dense. As you get to the cooler air, you get to optically denser air. So let's go ahead and put in more layers. There's 1.0, 1.01, 1.02, 1.03, 1.04, and then even 1.05. Okay, but we're not going to say that we have just 5 layers. 1, 2, 3, 4, 5, or 6 layers. We actually have an almost infinite number of very, very thin slices of air, each with a slightly more dense, optically dense index of refraction as you continue to go up. So now, let's take a look at another ray of light. We've seen a ray of light come in like this, and it bounces off, a ray of light coming like this. Well, imagine that a ray of light is coming off of this object like this, in this direction like that. So it's going to be coming down, say it's coming through here, and what's going to happen, let me make that actually a little bit more pronounced. So it's coming down, and it's hitting this next layer. Well, imagine that you have the normal, and what's happening is it's hitting an optically less dense material. Now, if you remember when the laser light went through the glass, it was going through denser, and when you go through denser, it bends light toward the normal. Well, if this is the normal here, and we're going into less dense, this is going to bend the light away. So I'm going to exaggerate that a little bit. Okay, now we have another normal. It's encountering less dense material. This is going to be bent even more away from the normal. Okay, here is another normal, and it's going to be bent even more away from the normal. Okay, what's going to happen is this process will continue to happen until it's perhaps running flat, and it could be even bent upward toward this right here. So let's see what's going to happen as we get over here. We hit the normal as this beam of light begins to approach the observer, and now what's happening is we're going from 1.1 to 1.2. This is going to bend now toward the normal. So it's going to look like this. Another normal, and then we're getting into something denser, so it's going to bend more toward the normal. The net effect is that this is going to be bent back to your eye. As the light's going down, it's bending away from the normal, and as it starts to come and approach upward, it's going to be bending toward the normal, and it will make it back to your eye. So what does the person see? The person can see the object with his or her eyes, but what's going to happen is this beam of light is going to appear to be coming from a different source. And it's going to be coming from this region right here. It's coming in their eye like this, but if you follow it back, it'll be traced back to this area right here. And so what they see is this is not a perfect image. This is going to be a perfect image because they're seeing the light coming directly, but this is after it's been refracted so many millions of times through those infinitely small layers of air. And so they see the image, but they also see this, which is the mirage. So here's the object over here that they see, and here is the mirage that they see. And this is, again, coming from the perspective of they're following these light rays back downward, and that's going to be the mirage down there. So hopefully that will help to explain mirages, and it's due to light being bent in these different temperature zones, in these different optically dense environments. And it's going to bend the light, and it will appear that that object is also coming from here as well, but it's going to be very, very distorted because it's been refracted so many times. So I want to show you how light will actually conquer the darkness. Imagine that you have the sun right here. And I'm going to draw the earth over here. This is not perfect to scale. And Earth also has an atmosphere. Okay, so here's the Earth. And since this is the side that's facing the sun, this, of course, is going to be day. And on the other side, it's going to be night. What happens is these rays that are coming in to the Earth like this will directly hit the Earth when they're coming in straight. What's going to happen, though, is this is a perfect vacuum. Okay, so the index of refraction of space is equal to 1.00. Okay, now the index of refraction of air, I said it was close to that of space, and it is. It's 1.0003, but it's just considered to be 1.00 if you're doing 3 significant digits. So what does that mean about the index of refraction of air? It's optically what compared to that of space? It's optically denser. So what's going to happen is, well, imagine that you have a beam of light that is coming over here that actually would be missing the Earth if we didn't have an atmosphere. It would just go off. Okay, but it's coming in, okay, and actually here is the normal. It's the perpendicular to that surface of the atmosphere. And what's going to happen when this beam of light hits the atmosphere? It's encountering something that's denser, and so the beam of light is going to be bent inward toward the normal. And what's going to happen is this light will then be able to hit a region that would not normally be illuminated. So this will also occur on the bottom side as well. Okay, and there's the normal there. It's going to be bent inward. And so what it's going to do is it's going to, instead of having a perfect 50% of darkness and 50% of light, this light will get bent a little bit through the atmosphere and will actually illuminate more portions of the Earth. So the Earth actually has more light than it does have darkness. So this is to show how the refraction of light, how light conquers darkness.